All right. Hello, everyone. Great to be here. Really excited to be my first time in Estonia, and a place I've heard a lot of great things about. So, thank you for having me. Yeah. So, as I said, my name is Mackenzie Jackson. A little bit about me: I'm from Aotearoa, New Zealand, originally, but I live now in the Netherlands, so it's a little bit closer. I work for a French company called GitGuardian. You can find me anywhere on social media at the handle Advocate Mac. And I'm also the host of the Security Repo podcast. It's my mum's favorite podcast. She recommends all of you guys to listen to it, so you can check that out if you want to. All QR codes in my presentation are scanned at your own risk. I'll promise you they won't do anything malicious, but you never know. All right, so if we could just take a moment to pray to the demo gods. I was meant to do a lot of demos during this. Hopefully we have it sorted out, but the demo gods weren't on our sides this morning. So hopefully everything will run smoothly right now, but we will see as we go. But in this presentation, we're going to be talking about exploiting secrets. And it's going to be a little bit of a black hat mindset of talking about this, of understanding how attackers operate, how they find and exploit these secrets. So what am I talking about when I'm talking about secrets? So most of you probably know this, but when I'm saying secrets, I'm generally talking about digital authentication credentials. Now, typically, these are things like your API keys or credential peers. It could be a security certificate. These are really the crown jewels of any organization because they authenticate services, systems, and sometimes people into different systems. Attackers are always after these secrets because it enables them to do something that all attackers want to do: elevate their privileges and persist their access. So secrets can be used as a way of gaining initial access. If they find a secret publicly or they purchase one, then they can use that to break into a network. They can use that to gain access to that system. It can be that first foothold. But it can also be used during an attack that they'll find along the way that they can use to then progress further, dive deeper into these systems. So attackers really like these secrets. And one of the things that we really need to understand about secrets is that these are made to be used programmatically. So that means that they're not meant to be used by a human, they're meant to be used by machines and services. But that means that they're a high candidate for ending up in places that they shouldn't be because they end up in our source code. And the reality is that secrets are absolutely everywhere if you know where to look for them. So today we're going to go through really four parts about different ways. These aren't the only ways to find secrets, but we're going to look at 4 different ways where you might be able to find secrets in different systems and how you might go about abusing them, how you might go about finding them. And then at the end, we'll look at what we can do to prevent this. So the first one I want to talk about is abusing the GitHub API. So you guys probably are familiar with this website here, GitHub. This is the most popular code sharing platform in the world. It has hundreds of millions of developers that use it. You probably use it. What's interesting about GitHub is that even though your organization might not use GitHub, the chances are the developers that work for you do, or personally, which means that your organization still has exposure to GitHub, and there's still ways of finding sensitive information, even if your organization doesn't use it at all. So just some facts about, some stats about GitHub. Last year, so 2022, I forgot the year for a minute, there was over 1 billion commits that were made during the year. So that's 1 billion commits that were made publicly. This is only talking about public information. With Git, you can have obviously private code and you can also have public code. But publicly, over 1 billion commits were made public last year throughout the year. There was 85 million new public repositories, and about 94 million developers using it. So what this shows us is it is an absolute fire hose of data, and when there's this much data, you're always going to be able to find really good information. So, as I said, I work for a company called GitGuardian, and one of the things that we decided to do at GitGuardian was launch a research project to find out how many secrets we could potentially find on GitHub. So what we did is we decided to scan every single public commit that was made on github.com. I'll explain how we did that, but all those billion commits, we scanned every single one of them in real time to try and find if there's any secrets available. Anyone here want to take a guess as to how many secrets we found on GitHub last year? Who thinks more than 1 million? All right, who thinks less than 1 million? All right, two brave hands. We found 10 million. 10 million secrets that were leaked publicly, I'm only talking about publicly, on github.com. And so a lot of people say, okay, but how do you know that they're real secrets? How do you know it's not a test credential? How do you know it's not a kind of some generic high entropy string? How can we be sure that what we're finding is real? Well, we can actually categorize these, and we did a lot of post-validation. So in the categories that we had, about 20% were for cloud providers. So 20%, 10 million, some quick maths, that's 2 million cloud provider keys that we found. And one of the things about cloud provider keys is we can validate these with the services themselves. So we actually found 2 million valid cloud provider keys on github.com. Again, this is all just public. And so you don't need to be very imaginative to know what you can do with a cloud provider key. You could do some crypto mining at the very least. If that key is for your organization or something, you can break in, maybe steal some data, maybe try and move into different systems. We also found lots of other interesting things, messaging systems, things like Slack tokens. These are actually really interesting for an attacker because it means that if I have one of them, even if I can only post a message, I can post a message internally to your organization that looks a lot more real. So it is potentially a way that I could get a foothold into the organization. And one of my favorites down there, 3.8% of what we found were version control platforms. So basically what this is saying is we've found access keys to your private Git repository that you've put in your public Git repository. It's a bit like putting the password in the subject line of an email. So there's lots of different things that we actually found in here, and a lot of them are really, really interesting. And they're not always just for individuals. A lot of the times, these keys are actually linked to organizations, and it's because someone has either mistakenly contributed code to the wrong repository, perhaps they're working on a personal project and not realized, or perhaps there's something in the history that they've forgotten about when they've made something public. So what has come to the specifics? Obviously, there's thousands and thousands of credentials, so we have a very long tail. But some of the more interesting one, Google API keys is one of the most popular keys that we find, including Google Cloud keys as well, AWS keys, and Google OAuth tokens. So a lot of these are really, really quite sensitive. But we find so many that one of the questions you might have is how do you actually find these keys? How would an attacker be able to find these keys and use them? So there is actually a couple of quite simple ways. The first one I'll talk about isn't my favorite, but it's the easiest, so I'll talk about it. And that's literally just using the GitHub search feature to try and find secrets in this. So in this case, we're looking for a file name called credentials, and we're looking for an AWS access key. This is just one example of this. Now, the reason why this isn't really my favorite way of doing this is basically because when it comes to Git, when it comes to your source code, what Git does is it keeps a track of everything in the history. And that's actually where most of your secrets are going to be. When you're using the search function, it's only looking at the top layer. And that's a drop in the bucket of all the source code that's actually available if you know how to look for it. You're also going to find some real secrets in here, but you're going to find huge amounts of false positives. So you're going to spend all day doing that. There are lots of different types of what we call dorks, GitHub dorking, where you can copy these and try and find some interesting things. But luckily, there's a much easier way for attackers. Attackers don't have to go through all that effort. They can do it much easier, and they can use the GitHub API. So the GitHub API is at this address up here, api.github.com/events. You don't need any authentication to view this. Anyone can. And what this is it's a real-time ledger of everything that's happening publicly in github.com. So how did we scan every single billion commits? You may think maybe we have some kind of partnership with GitHub. No, we don't. We just use the GitHub public API. Now, you may think that this could be an abuse of that system, but it's not, because there's so many services that do similar things using this API. We're simply just using it for the same way. Now, nefarious actors are also using this. So what we want to look at here is there's a couple of different events that get pushed on this API, and the two that are most interesting are the public event. So this event is when a private repository is turned public. Now, why this is such an interesting event to look out for is that when you make something public, you make all the history that you have done public with it. So if a developer 2 years ago, working on a remote branch, committed a secret, even just briefly, that secret now exists, and when you make the repository public, you make that secret public. And the other one is the push event. This is just when code is pushed to public GitHub. So attackers are often looking into this. And what you can do is, what we've started doing is starting to purposely leak some secrets in the GitHub API to monitor what attackers are doing them and how long. So it generally takes the first attacker less than a minute to be able to discover the secret that you push on GitHub. And that's not because someone is looking at it. This is a bot that's using probably some basic regular expression to try and identify specific keys, test if they work, and then move forward later on with an attack. So today I have a workshop on creating honey tokens. These are fake credentials. And what we'll do in that workshop is leak some of these on public GitHub and see what happens. So it really takes about less than a minute for the first ones to actually start being discovered. So attackers are really using this in their methods. So let's talk about a scenario where a public key has been leaked and was actually discovered. So there's been quite a lot, but last year we also had some news around a company called Toyota. It's a small car manufacturing company. And Toyota have a mobile application called T-Connect. Now, T-Connect can do a lot of things, including starting your car, so it's quite important. But Toyota actually uses a lot of contractors in their work. So this is where things start to get interesting, and it paints a story of how keys may leak on GitHub, even without your knowledge. So in 2017, there was a contractor that was working on the T-Connect mobile application with Toyota. Now, that contractor accidentally pushed code to a public repository in December. For 5 years, that code sat there publicly without anyone really noticing. What was in those code was hard-coded access credentials that gave access to all the data of all the users that were using T-Connect. So eventually, in 2022, a white hat hacker actually discovered it, a security researcher discovered it, and then reported it to Toyota. But that key was accessed and valid for 5 years on public GitHub. So you can actually be certain that someone else had found that and was starting to abuse it. And Toyota can't comment on whether or not that actually happened, because going through 5 years of logs to try and find malicious IPs is really quite a big challenge to do. So this is an example of how, even if you're not publicly using GitHub, even if you're not thinking that, hey, I don't have any public repositories on GitHub, I don't need to worry, there's lots of ways that keys can still leak to this. All right, so that's kind of the first part, looking at public code and trying to find secrets and exploit secrets inside public code. So the next part that I want to talk about is private code, because this is far more interesting for an attacker if they can gain access to it. With public, we have to deal with huge amounts of data, and we're going to find interesting things, but part of the security of that is that there's so much for us to look at and go through that it's hard to identify what's actually of interest to us. But if we can get access to the private source code, well, this is much more interesting. So there's been lots of leaks that have happened. Private source code is really terrible at staying private. And if we have a look, we had some leaks, like Microsoft had their source code leaked, NVIDIA, Samsung, and all of these companies I would consider have fantastic security posture. I don't think that anyone could say that Microsoft has poor security. Maybe you can. I wouldn't make that call. So how does this source code from these massive companies, something that we'd probably consider to be a high-value target, how do these actually leak? Well, the Lapsus group was really prolific in trying to discover source code on there and leaking it out. And really, one of the methods that they were doing is just buying access from employees. When it comes to private source code, so many people have access to it that if there are secrets buried in there, and I can almost guarantee that there are, then all of those people have access to those secrets. And a malicious actor can either try and phish them, try and purchase access, or do different things to discover it. Now, one of the things we also did at GitGuardian is we decided we scan private source code for secrets. And so we had a look at how many we would find. Now, this next slide involves some maths, so forgive me. But really, in an average company with about 400 developers, so it's not huge, but it's also not small, would typically find about 1,000 unique secrets. Each of those secrets occurs about 13 times, so we do maths, 13,000 secrets we typically find. Now, in a company with 400 developers, there's probably going to be 4 AppSec engineers. So each one of those AppSec engineers is going to have to then investigate that leak, try and figure out what that secret is for, revoke that secret if they need to, issue a new secret, and then redeploy all the code without creating any downtime. And if we divide 13,000 by 4, we come to around about 3,400-ish secrets that those AppSec engineers have to do every single year. So that would be their entire job. So why is secrets in source code such a problem? Well, secrets often end up inside them, and the problem is so large that it's almost impossible to solve. So you do the next best thing, which is ignore it. And then when someone gains access to your source code, you can end up in quite a bit of trouble. So if we take a look at one of these actual leaks, we'll have a look at the source code leak of Twitch. So Twitch had all of their source code leaked, which included 6,000 repositories, and it was 3 million documents. We scanned this leak. It was involuntary open sourced, let's say. We scanned it, and we found 6,600 secrets that were inside that source code. That may seem like a lot, but actually that's pretty good. If we only find 6,600 secrets in your source code, and you're that big of a company, you're probably doing okay, because this is how big this problem actually is. But in saying that, we still found 194 AWS credentials, 69 Twilio keys. We even found 4 Stripe keys inside their source code. So this is a huge problem. So what does this all mean? Well, this means that attackers are really after your private source code. If they can get access to your private source code, then they can get access to a whole bunch of secrets that live inside there, and they can potentially move into different systems and services. Right, so how is private source code accessed then? How do we actually access this private source code? Well, there's a bunch of methods. I've mentioned a couple of them that attackers are doing. The first one is the least exciting, but definitely one that happens, and that's purchasing access. So I mentioned the Lapsus group. This is actually a group of teenage hackers that were mostly after clout. And they've got access into, as I said, Microsoft, NVIDIA, Samsung, all these companies. So how do they do it? Well, if you look at their Telegram channel, they're literally just posting advertisements saying that they will pay you if we can give us access to your network or to your source code. So if you look at, who has access to your source code and how many of them may be having a bad week that day, then you can think of lots of ways that people might find this attractive to grant access to it. We also have phishing. Phishing that's really targeted at developers. Here, there was a campaign that was targeted at developers that were making Chrome extensions, trying to get access to their source code. So this is another way where developers are really being targeted in phishing campaigns to get access to it. We also have exploiting misconfigurations. So one common misconfiguration of Git is that you accidentally expose your .git directory. This is a folder that has all the metadata of your source code in it. And you can recreate the entire history of that Git project from that. These are quite often discoverable in public places. And the other one, which is quite difficult but definitely happens, are supply chain attacks. So we've seen one, a good example was CodeCoV, where the attackers were able to gain access into private source code repositories by turning this tool that sits in the CI/CD pipeline malicious. I'll talk a little bit more about that. But what I really want to talk about for this presentation is I want to dive in on exploiting the misconfigurations. So I mentioned about finding those .git directories. So what actually happens is this folder accidentally gets included when code when applications are published, and then that can be discoverable on networks. So a great organization called Cybernews did some wide-scale scanning on this, and they actually discovered that there was 2 million .git directories that were exposed publicly after doing some scanning. So again, this is a huge, widespread problem. So then you might have a look at, okay, how do I actually go about finding these .git directories and actually starting to do them? So I have my first demo here. We'll see if it works, but this will be video 1, where we will take a quick look at how we can actually start scanning some of these systems. So it's really quite simple. How I like to do it is I use a system called Subfinder. Here we are. To basically discover subdomains. So in this case, I'm going to be looking for Algolia. I've picked Algolia because I know they don't have any exploitable misconfigurations, and I didn't want to. I don't know if that's playing. But anyway, I'm using Algolia because I didn't want it. And essentially what we're going to do is we're just going to use this tool to be able to discover as many subdomains as possible for this. And we find quite a few hundred. And then we can actually look going through here. So we've found 267. And so what this means is that these are all the places that I could potentially look to see if any source code has been exposed on these subdomains. And so then what I'm going to do is I'm going to use a different tool, which is going to take this list of all the subdomains, and then we're going to try and discover if there's any kind of .git directories that I can actually extract from these. So this is just a tool. This can scan it, and then it will also dump it, and then lastly, it will reconfigure it for it. Oh, something happened there. All right, we'll move on. So we can extract the Git directories using using a Git scanner tool. So these are the tools that I used. Subfinder. We have Git scanner to expose them, and then the last part of that is I will recreate those Git folders, and then I'll scan them using a tool, for instance, GGShield. And you can find lots and lots of different secrets using these methods. If you want to have a look at more misconfigurations, there's a really cool program called GitGoat, which basically is a pwnable Git configuration, and you can actually have a look at all the different ways that you can exploit misconfigurations using this. So the last one, we've talked a lot about source code. I am going to move on from source code, but why are secrets such a problem, particularly in source code? And a lot of it has to do with the history and how we build. So I want to show you a scenario because I'm sure there's some developers sitting here saying, other people may leak secrets, but not me. I'm not an idiot. I'm not going to publish a secret in here. But here's a common scenario that we would see. You have our main branch. If you're not familiar with Git, this may look a little bit weird, but you have your main branch, and this has all the source code that's potentially out in public. And then on that, you have feature branches or different kinds of branches which enable developers to work independently on projects and then merge it in later. So in this case, what we have is we have a developer who's working on a project, and let's say that project is to try and connect into a system, into a database. They need to get data from an AWS S3 bucket or something like that. So just to test the project works, they hardcode a secret, and then because they know they're not meant to do that, later on they'll make sure that they remove that, which is happening here. And then a couple of hundred commits later, it'll be time to merge this into the main branch. That secret is no longer visible to the person that's doing the code review because they're only interested in what's the latest version of the main branch and what's the latest version of your feature branch and what's the difference between the two of them. What they're not interested in is 200 commits ago that you submitted a secret. But once that code gets merged in, that secret still exists. That secret still exists in that history. And then a lot of people say, yes, but I use something like git squash. I squash all my history. Well, this secret still exists. It's just in your bin store. And so unless you do a garbage dump, then that secret still exists. So secrets really persist once they get into Git. It's extremely hard to get them out. So this is why secrets so often end up inside Git repositories. Some other areas, it might inside logs and auto-generated files. If you do a debug log, often that might dump out your environment, which has environment variables in it, which are often secrets. If you're not using a .gitignore file, all kinds of different things can end up inside there. A lot of people have secrets.txt or something on their desktop that accidentally gets captured in. They can be in template files, so Django creates Django keys automatically, and unless you know they're there and remove them, then they can end up quickly in there. And then obviously it's just sharing on Git, not understanding how easy it is to access source code for attackers. And finally, hard coding secrets. We see that a lot. All right, so I want to move away from kind of source code. I want to start looking at how can we find secrets and abuse them in other public areas, and for instance, in registries or in containers. So I want to have a look at Docker images and how we can actually find secrets inside Docker images. So just quickly, this here is what a Docker image actually looks like. So what's in green here, these are source code files. So when you think about Docker, a lot of people think that this is like some kind of black box. But actually, if you look in here, there's a bunch of Python files. This is source code. When you compile your Docker image, you still have extractable source code in there. And what we can do is we can simply, I'm using a tool here called GGShield, and we're just scanning this Docker image. This is one that is vulnerable, but they're not real secrets. I just want to show you how quickly and easy it is to do. And essentially, this is extracting all the source code, extracting everything interesting from the Docker image, including the Docker file, and then it's going to present if it finds any secrets in here. So here we have some bearer tokens that potentially could be dangerous. We have some API keys in here, and we also have some other passwords and other areas. So this is just a quick example of how easy it is to be able to identify Docker secrets inside Docker images. If we could go back to the slide, yep, perfect. So this here is DockerHub. So this is like the equivalent of GitHub, but for Docker images. And there's about 8 million, or 9 million now, Docker images that are hosted publicly on here. So also we decided to have a look at how many of these Docker images actually contained a secret, a hard-coded secret. How big of a problem are leaked credentials inside Docker images? So after scanning 10,000 images, we found about 5% of them exposed at least one plain text credential. So this is actually huge. And there's been some new research coming out of a university in Germany that looked at 300,000 Docker images and found that about 8% of them contain secrets. So this is actually a pretty massive problem. And again, all these Docker images are actually publicly available. So as an attacker, you don't really have to look very far. You download 100 Docker images, you're probably going to find at least 5 of them that are going to be vulnerable and have hard-coded credentials inside them. So does this actually happen? Have attackers been able to find secrets in Docker images and exploit them? Yes, they have, and a couple of them have been quite nasty. So I want to look at one here. This is one from a company called CodeCoV. You might have heard of it. I actually really like CodeCoV as a company, but they did make a mistake, and it affected a few people. But CodeCoV is a code coverage tool. It sits in your CI/CD pipeline, and it's how it sits in an area where you build and test your application. So if you're not familiar with all of that, here's what you need to know. CodeCoV tests how much of your application is being tested when you're testing your application. So it does a very specific job. It's important to know what your code coverage is, how much you are testing, but this isn't something that you would assume would have critical access to anything. So what actually happened? Well, CodeCoV, how you often ran this application was that you downloaded the public Docker image and you used that in your CI/CD pipeline. That public Docker image had a hard-coded credential inside of it. That credential gave access to some source code. This source code was hosted on a Google store, I believe, or some kind of storage, and the hard-coded credential gave the attackers read and write access to be able to manipulate that. What they were then able to do is turn CodeCoV malicious. They injected one line of code, and that line of code did this. It said, every time someone runs CodeCoV in their testing environment, I want you to dump all the environment variables, and I want you to send them to me, the attacker. So if you don't understand what that is basically when you build your application to test it, you need a bunch of credentials to be able to do that properly. Those credentials sit in your environment. And essentially, this one line of code said, take all those secrets, all those passwords, and send them to me. And the attackers are really only after one type of password, though, because they were after access to private source code. They wanted your GitHub and Git access tokens. And they were able to get that. There was 20,000 targets in the end, and they managed to gain access to a lot of private source code. So this kind of goes back to gaining access to source code through a supply chain attack. So this is an example where a leaked image really ended up with these attackers being able to move into huge amounts of different resources. And this was a big problem. So some of the companies that were affected by this were quite large companies: Monday.com, Twilio, Hashi Corp, Rapid7. All of these companies had their private source code accessed due to this misconfiguration, or we can call it that, this mistake. Now, I very rarely pick on any companies that have a breach because I believe that it can happen to anyone, and we just need to deal with them. But I am going to pick on one company just briefly. And that company is Hashi Corp. I hope no one works here for Hashi Corp. But I actually like Hashi Corp. I think it's a great company. Please don't sue me. But Hashi Corp created a product called Hashi Corp Vault. It is probably one of the best secrets managers available on the market. It can do all kinds of really great stuff. Hashi Corp coined the term secret sprawl, which is this unwanted distribution of secrets. And part of their selling platform was that if you use Vault, then you don't need to have secrets in your source code. We can really solve this issue of leaked secrets. Hashi Corp, because of this attack, had to announce that they had a private key that was inside their source code, which was accessed by an attacker. So if Hashi Corp have secrets in their source code, the rest of us have absolutely no hope. Okay, so move on now. So how do secrets actually get inside Docker images? Here's this one example that I've seen a lot of. Again, if you have hard-coded secrets in your source code, they're going to end up in your Docker image. If you understand Docker, this may look a little bit familiar, but we can also get secrets in what we call our Docker file, which is how we build images. And in this case, like I said with Git repositories, your history is maintained. Well, Docker is built up on layers. So if you add a secret in one of the first layers, and even if you delete it later, we can still go back at it. So and this is a scenario that I've seen. You have a .netrc file, which contains credentials to a package manager, generally. And what this is doing is it's basically saying, hey, I want you to use this netrc file, and then I want you to remove it at the end. And the person then thinks that because they've removed that, then it's not going to be in the Docker image at the end. But we can go back through the layers and actually access it. So that's just one other way that we can do it. All right, so I want to move on away from Docker images. I want to talk about one other type of application before we move on, and that's mobile applications. Mobile applications are an absolute treasure trove for secrets. You can find them absolutely everywhere. And this kind of comes down to a big misconfiguration or a big misunderstanding that we see in security a lot. And that is that if something's non-human readable, it means it's secure, right? So what do I mean by that? It's kind of similar with Docker images. When you compile something into a way that's not really extractable for you, it looks like mumble jumble, it's been obfuscated, then we think that that makes that secure. But it's absolutely not the case, and it's especially not the case for mobile applications. So there's generally two types of mobile applications. If you're using iOS, then you're going to have an IPA file. And if you're using Android, you're going to have an APK file. This is really the file that at the end of the day, when you construct your mobile application, when you compile it, it spits out one of these files. So what are these files? They're not very friendly. They're not that human readable, but they do contain a lot of great information. And they're essentially glorified zip folders. I'll talk about that. And that just means that they're extremely easy to extract it. So we have the last demo that I want to do here. If we could play video. Yep, perfect. So what I'm doing here is I have an application here, app1.apk. This is an Android mobile application. I'm using a tool called JDEX to basically decompile this. And what I want to show is how easy it is to kind of get back to some kind of readable source code. Now, when it comes to mobile applications, you can find secrets everywhere, but there's a couple of key places. The strings.xml file in Android applications, or the Android manifest, are particularly of interest. And as you can see here, we've now gone back to a point where we have this original source code of this mobile application. So we can see it. Now, a lot of the things may have changed. The names of the files may have changed. It may be a little bit harder for me as an attacker to really understand everything that's going on in here. But luckily, we have tools. So all I'm doing now is using the same tool I used before, GG Shield. There's other tools you can use as well to scan secrets. And I'm just going to look inside this Android application, and I want to find some secrets. So this will take just a couple of seconds. But to talk about this particular application for the moment, this is one that I downloaded from the Play Store. This is a real application. It's available. I've masked the name, and I'm not going to expose any of the secrets, but this is quite real. I downloaded 10 applications to trial of this. 4 of them contained secrets. One of them was far too vulnerable to show anyone, and this was kind of the next best thing. So this is really a massive problem, and we'll talk a little bit about it. All right, so now that this has been decompiled, again, I want to point out that this is real. What do we have in here? So once we get to the top, we'll go through some of the secrets, not all of them, but you can see there's a lot of secrets that it's discovered. So what's the first one? We have generic password. Here we have a Slack webhook ID. Now, as you can see, this is valid. So we've done a test to see if we can actually use this. So that means that I potentially could post something in Slack channels. This is really helpful. A Slack webhook ID, in most cases for an Android application, will be like crashing logs, send information about when an application crashes. So I could post something in there to try and gain further access. We have some generic passwords. Here we have a Google API key. Again, this is valid. And we have some other Google API keys as well. And a few more. We'll keep going, but we can. I think we can stop here. And here you'll see the file that they're in. So this is in a Java file. The name won't mean anything, but it's just been hard-coded in there. And if we can now get on to the next video, it should be the last video that we have in here. So here, I want to talk about the IPA. How do you extract data from an IPA? We had to decompile the last one. All you need to do for iOS is change the extension to .zip. Once you change the extension to .zip, you can then extract that and get back to the source code very easily. So here, if we take a minute, once this gets extracted. So Android is, if you want, I wouldn't say Android's more secure. Android just has an additional step, but iOS, you really, it's, when I say it's a glorified zip folder, it really is a glorified zip folder. And then once we have the application, all you need to do is get rid of the .app at the end, and then that will give you a folder containing all of the source code. And then you can go through the same process of being able to scan this for secrets in the same amount of way. And if we could go back to the slides now. Perfect. Okay, so in case you're wondering, how did I do this? It's all using open source tools. GD Play Downloader is how you can download an APK, because you can't do it without a mobile, but you can trick it into thinking that. JDAX is what I use to decompile it to get back to human-readable source code, and then I scanned it with GG Shield like I did, and I'll talk about some other scanning tools that you can use later on. We'll skip past this. Here we are. And decompiling Apple applications, there's a tool called IPA, download IPA, which is or IPA tool, which is a way to download applications from the Apple Store. Change the extension from .ipa to .zip, and then you can scan it for secrets. So does this actually happen? Do secrets actually get leaked in mobile applications? Are there examples of that? Yes, they do. There's huge amounts. I want to talk about one example now. So here we have a story. This is from a white hat hacker called Jason Haddix, who's the CISO of Buttobot, which is a pen testing company. Jason talked about this on my podcast of how he did this, but he still does some penetration testing, and he still does some bug bounty programs. And then one time he was working on a project for a tier 1 bank in America. This bank had a mobile application, and part of that they had an APK, obviously, that he could file. So the first thing he discovered was that this application was taking images of checks. I don't know why, but apparently in America they still use checks. And part of this was that you could take a picture of the check and you could cache it using your mobile application. What then happened is that he realized that those checks were being stored, those images were being stored unencrypted on your mobile device. And he figured that if they're being unencrypted on the mobile device, that means they're being sent unencrypted somewhere. So he found out that they were being sent to an Amazon S3 bucket for storage, and that S3 bucket conveniently had a key hard-coded for it inside it. So he then was able to use that key to access the Amazon S3 bucket and gain access to 10,000 unencrypted images of checks. Again, this is for a financial institution. This isn't some fitness app that someone has kind of built in their basement. We're talking about pretty serious applications here with serious use cases. And so the reason why I'll often see something like this is that the correct way to connect to services is through a backend. And you should always go through your backend so that your secrets aren't ever exposed. You don't have secrets on your application. But a lot of people think, well, if I go through my backend and then I have to go to the storage, I'm kind of creating an extra step in there. It's much more efficient to go directly to the storage. And the only way to do that is to hard-code a credential, which, as we know, is wildly insecure and can create problems like this. So thank you, Jason, for sharing this story with us. So how big of a problem is this? Again, Cyber News did some great research. They found that about 56% of mobile applications contain at least one hard-coded credential. And when you look at some of this, is that Google Bucket Storages, which is in line with what I was just saying, was the number one thing in there. Now, not all of these are going to be extremely sensitive that will create huge problems. A lot of them will be keys for messaging systems, which won't allow you to do anything unless you've done a misconfiguration on the server. But it's still showing a really poor practice, and with still huge amounts of examples of how to gain access to these secrets in here. All right, so I'm almost out of time. So now I just want to briefly mention, how do we avoid this, right? So I've gone through 4 examples of how to find secrets in different ways, from compiled applications, from source code. How do we actually prevent from doing this? So the first one should be obvious, but apparently not. Don't hard-code credentials, right? So even for it. So this is our API key equals 123. Hopefully that's not a real API key. But basically, this is the easiest way to do it. It helps you get moving forward quicker. Even if your intention is to remove it later, don't do it. Handle the secrets correctly from the start, because it will end up in your history and it will create problems for you. Now, some other things that we need to talk about is how we actually store secrets correctly. So we want to store the correct secrets manager. And this doesn't always mean that the best one is the right one for you. Because sometimes products like Vault, Hashi Corp Vault, are too heavy if there's 4 people in your team. So you've got to make sure that you pick a secrets manager that's going to do the job for you. There's a couple of examples, Vault and Vaults are kind of up there at the top. Then you might have some other ones. We've got 1Password has some cool tools. A Keyless, Doppler is another one. These are kind of SaaS solutions that help you manage your secrets. Cloud providers that also have secrets managers in them. These lack a lot of the features that the dedicated services will have, but if you're using them, then at least you're not hard-coding them in credentials and in your source code. And then the last one is, you can encrypt your secrets and store them inside Git. Now, every single security person will tell you that the last one is a bad idea, and I agree. It creates a single point of failure. It's really not a great practice to have your secrets encrypted in Git. However, if this is going to prevent you from at least hard-coding your secrets for the time being, then that's better than storing them in plain text. So I'm always like, let's get to the first step and work towards having a vault in the end. But as long as you're not hard-coding them in plain text, then I think you can be forgiven. All right, some other tips. Use automated tools to detect secrets. I work for a secrets detection vendor, so anything I say about this is going to be wildly biased. So I use GitGuardian. There's open source tools like GG Shield, which is what I used, and there's lots of other open source tools. Trufflehog, Git Leaks, Yelp Detect Secrets. The point of this is to say, it doesn't matter where you are, it doesn't matter what kind of budget that you have, there are free tools available for you to be able to detect secrets. So you absolutely should be doing this and using these tools to be able to, because the bad guys are using them. Use Git hooks. This is another one of, once a secret enters your Git repository, it's kind of there forever. The only way to then do that, to deal with that, is to revoke it. But if you use a Git hook, you can potentially stop them from coming into this repository in the first place. So this will, pre-commit or pre-push Git hooks actually prevent you from leaking secrets in the repository. So it's a great way to get on top of it and actually stop the bleeding. Rotate regularly. Use limit privileges. Just because having an admin key is more convenient doesn't mean that you should do it. Whitelist different services and IP addresses, so limit who can actually access it. If one particular service is meant to access something, then make sure that only that service can. And with 5 seconds left, that's the end of my presentation. If you want to find out more, the State of Secrets Sprawl has a lot of the research I was presented, and this one here, it goes much deeper into how to actually manage your secrets. So I hope you found that interesting, and